Hi viewer, this is EasyElimu channel. I'm Vincent Kanumai and today I'm going to guide you through Form 2 Mathematics and we shall be handling the topic of similarity and enlargement. Now let's consider similar figures, and here I have drawn two kinds of triangles. As we can see, they are of the same shape. They look similar in shape but different size. As we can see here, the corresponding sides as this one, you will find they have a certain relationship with that of the other corresponding side. I mean the corresponding side WX of the first triangle with that of PQ. You will find there is a relationship. The same to PR and WY and even QR and XY. As you can see here, if you construct a given figure, two given figures that are similar, you will find out that their corresponding angles, for example here, this kind of angle A, will always be the same or equal. The corresponding angles will be equal. In similarity and enlargement, so as to say that a figure is similar to another, the corresponding angles of the figure must be equal, and another condition is that they must be of the same shape. Another one is that the scale factor must be also equal, meaning that the relationship should be constant. So the scale factor must be constant. In that, for our case here, to find out, since the first rule is fulfilled in that the corresponding angles of the triangles are equal, then what we should do here is to find the scale factor. Now the scale factor is that we shall take this over the corresponding side so that it will be W. If we take WX over PQ, because that is the corresponding side, we should find out that it is equal or constant, because WY should be, if we take WY and corresponding side of the other triangle, which is PR, we should get the same thing. The same should apply to XY over QR. Don't reverse and take QR over XY. You will get a reverse of your answer. But here, this is what you should do. You take the side here and its corresponding side on the other similar figure. You find that this one here should be constant. If not constant, even if the angles are the same, that figure is not similar or to each other. They are not similar figures. So here for our case, if we work out, we are going to have, for example, if we take the first one is 6 over 18, 6 centimeter over 18 centimeters, so it will be 6 over 18, should be equal to 5 over 15, which should be equal to 8 over 24. And you will get this one is 1 over 3. So this 1 over 3 is constant throughout, in that if you take 6 over 18, you will get 1 over 3 or a third. Even 5 over 15 will give you a third, and also 8 over 24 will give you a third. That constant here is what we refer to as scale factor. That is our scale factor. So meaning that two figures or 3, 4, or let's just say 2 and more figures are similar if they have a same scale factor or a constant scale factor, and the angles, the corresponding angles of the figure, the two figures are equal, and also the corresponding sides have that, the corresponding side creates that scale factor, so that we can say two or more figures are similar. So that is how we conclude it and how we may find it. It is different ways. So this can be applied in mathematics, in that you will be given two similar figures. Then you may be given either of the side, complete side, some angles in, some missing, even sides some may be missing, but others be given of one of the figure. After there, then you may be asked to compute either of the side. For example, you may find you will be issued with that, maybe with that, and then here they have denied you that kind of information. Then you are being asked to find this side, maybe this one may be X, this one here, Y. And you may be issued with this side, for example, let's say this side here, it may be 30 degrees. Here, you may be asked to find, maybe this one be issued like, let's say, 70. And you'll be asked to find here, and here, just that way. And you'll be asked, find the angles A, B, C. As C here now will be 70 because here is 70 already. So you may be asked to find the corresponding angle. So there you just have to find angle B. So that is how we do work it out, and using that relationship we can find it out. Next we shall review out how numerically it is done. For example, you may be issued with an example in that you will find some figures here. For example, a rectangle. Sometimes you may find some figures are looking similar. Even the angles are the same, but the sides, the corresponding sides are not the same. You can find sometimes you have like this, and here you may have 2, 4, and here is 5, 9. Then you are being asked to state whether these two figures are similar. For example, in this case, you will find out that the corresponding sides, this is a rectangle. The two rectangles, if you view it on your bare or naked eyes, you will seem to say or agree that it is similar to the other, or one of it is similar to the other. But that isn't the case. Though the corresponding angles inside the rectangle are equal, since they are all 90 degrees each. But the sides, the corresponding side does not give a constant, or the ratio of the corresponding side doesn't give a constant. In that, if we take like this side here, actually this should be 9, this one should be 5, to make that be reality. In that, if you take 2 over 5, we should get 4 over 9. And that is what we refer to as scale factor. But for this case, 2 over 5 is not equal to 4 over 9. So meaning that this one here does not give a constant scale factor. Since if that is the case, then that simply means that the two figures are not similar to each other. And with that we can say that some figures may have some of the rules or entails that figures should have in order to have or to be similar figures, but the corresponding sides does not give a common scale factor when you find the quotient. So that's how we do it. On the same similar figures, you will find out that in case you draw some of the triangles, may it be isosceles or equilateral, 2 or 3, or even some may draw 4, but if you draw the triangles and you find out that all the internal angles of those triangles are similar and equal to each corresponding angles, then we can say the 2 or 3 triangles are similar. But if it doesn't, then we do say they are not similar. But sometimes you will find the ratio of their corresponding sides are also constant. If you find in that case, then the triangles, we can say those which have the ratios of their corresponding sides constant, then we shall say they are similar. Let's learn more about enlargement. And under enlargement, you will find out that you will have some of the figures which one of them actually under similarity you will find they are similar, but one of it is much more larger than the other. For instance, we have some here, one is smaller and another figure is large. But you will find they are having a certain similarity between them, in that, for example, here, ABC being a smaller figure to ABC prime, you will find this one here is the image of this because it's having primes. But on just deducting some of the information, you will find out that taking this to be the origin or as the center of enlargement, we can call the point where the lines of where the vertices of the two, that is the image and the object, meets. We do call that as the origin. Where the vertices, if you draw a line joining the vertices, then we do call that the center of origin. For instance, you can view this line here, OA, that is the vertex of a triangle ABC, and you can see they are joining at O, the same joins A prime, and here we can see, as you can see it out. So we want to deduce another kind of similarity information, in that this was our first or initial object. But under a certain given condition, we have obtained this, which is just similar like this, but this is larger or more large than the first object. The process of obtaining a larger object or a smaller object from the real object we had, let's just call this image, is called enlargement. So we can just conclude by saying enlargement is the process of either obtaining a smaller image or a larger image from a given object under a given condition. For example, for this case, we had this as our object and then it has enlarged to give us this larger image. So we want to see under what condition did this small object turn to be much more larger image like that. So what we have here, you will find out that if we take the ratio, or for example, if we were given the size, you will find this side may be 2, this one here is 3, and this is 8. And this side here, after enlargement, this one turned to be 6, this one turned to be 9. Now this one 8 centimeter, 2 centimeter, and 3 centimeter. But you will find out that in case you want to find the scale factor of enlargement, we do call it the scale factor of enlargement, in that the condition that was used to raise this object from the smaller part of where it was to a larger kind of it, then we shall take, if you take OA prime over OA, whereby this is a quotient or the ratio of the distance from the center of enlargement to the vertex of the image with the corresponding distance from the center of enlargement to the vertex of the object, like here, should be constant, in that even if we take OB prime over OB, we should get the same as OC prime over OC. Such is what we call scale factor. And for this case, now shall not only be called scale factor, but we shall introduce another name known as linear. Now it will be linear scale factor, simply because it is doing the purpose of enlargement only in one direction. So it will be linear scale factor. So our linear scale factor on calculation for this case, we shall find if we take OA prime over OB over OA, we should get the same as we have said here. But remember one thing, since this one is also enlarging, the same applies to the image. So meaning what we shall find here is still the same as taking AB prime over AB, and A prime B prime over AB, and also AC prime over AC. This is the same as B prime C prime over BC. You should get the same kind of information. In that, in case you have been told this one here is 6 centimeters from there to that point, then you can calculate out and find what is the corresponding value of OC prime. If you have been told to find X and Y, simply you can get the values of X and Y. I mean, X is from here to this point and Y from here to here. So using the relationship which we have just given out, we can still find out what we want. In that case, we can say that since we have the measurement of the other internal system, so you will say, for example, here we can decide to take any. For example, if it's OA prime that way, so let's just take inside first. That is A prime B prime, which is 6 centimeters, over AB here 2 centimeters, should be the same as A prime C prime here 24 over AC, which is 8. We shall still get the same thing, and that is 3 units. That's what we refer to as linear scale factor. And since we have found linear scale factor, if we need to find OA, then we shall say, if we take OA prime over OA, we shall find 3. That is the linear scale factor, simply abbreviated by LSF, linear scale factor. So if we do that way, we shall have, since this is X, OA, it will be X plus 16 over X is equal to 3. If you want to find the value of X, now you are required to find a cross multiplication of what you have, and in that case we are going to end up with 3x being equal to x plus 16. In that case, you will find out that 3x, now you, in order to get x, you are going to subtract on the right hand side x, so as to eliminate it, and also on the left hand side you will subtract x, and you will have 2x is equal to 16. You are going to find your x as 8. So x equals to 8 centimeters. So meaning the distance from here, from the center of enlargement to A is 8 centimeters, as you can see. So you can play out with the figures you have been given, so long as you know the relationship. Remember, it's not this over this. Yeah, I mean OA over, or the quotient between OA and A prime. No. It is from the center of enlargement to the vertex of the image over the distance from the center of enlargement to the vertex or the corresponding vertex of the object. That is how we do find the scale factor. The same applies inside, in that you take the corresponding side of the image over the corresponding side of the object. You will find that scale factor, and that is how we do. So I believe with what I have done, you can now evaluate the value of y. Now you find the value of y from what we have done. That is how I believe you may encounter some of the problems facing that enlargement, and you will be required to find it out. Having been given the scale factor, one of the side, you will find it. Or you may be given the two sides which are similar, or after enlargement you have been told it underwent an enlargement under a given scale factor, then you are required to find the scale factor. That is still how we do it. You use the image and the object to find the corresponding required solutions. Sometimes situation may arise whereby you may be given the measurement of certain figures and their images. So you will have the measurement of the object and the measurement of the image, and you'll be told to calculate maybe the distance from the one of the point of the image to that of the center of enlargement. For example, you may be given that you have triangle PQR, whereby PQ is equal to 3 centimeter and PR maybe 6 centimeter and QR is 4 centimeter. Then you have been told that P prime Q prime is maybe 9 centimeter, and also you'll be told to find that now the other one is PR primes, maybe now this one B18, and you may be told that Q prime R prime is let's say 12 centimeter. And you'll be told draw to show the center of enlargement and state the scale, linear scale factor. What do you do here? The first thing, find the linear scale factor first from this perspective, whereby you will say if you take P prime Q prime over PQ, you will get linear scale factor, or in either way. So if that is the case, now P prime Q prime here we are having it as 9 centimeter, and PQ we are having it as 3 centimeter. If you cancel out the centimeters and 3 into 9, you will get is 3. So that implies that our linear scale factor is 3. And remember, it has no units. So our linear scale factor is 3. So if you have that, I believe you can construct the center of enlargement, and that one may be, let me just give you by a sketch. You will first construct your triangle, for example, P, whereby you have, let's say this one be PR. So you will find that a sketch may look like this. That's just a sketch of the image and object as given. But remember, the scale factor is 3. So even if you haven't been given the scale factor, you could do it by joining P to P prime. Use a ruler to join P to P prime. If I say a ruler, this is what I mean. Join P to P prime and protrude it outside, so that you may have condition like that. After doing that, join Q to Q prime. After joining Q to Q prime, and also join R to R prime. This is just a sketch, but on real doing you will find it out. Maybe let's say after joining, you will find that maybe this one comes until they join at a certain point here. Let's say they join at this point here. So you find the 3 lines joins at this point. If you construct it, you will find the exact construction, and you will find the lines which are joined by a ruler are to exact point. They join at exact point. After doing that, the point where the line intersect is where we do refer to as center of enlargement. So you will find this scale factor from calculating from OP prime to OP, and we have found that value is 3 centimeter. So that is how we do construct. So you will say, you will draw, then you state the scale factor. That is the first condition. And another condition, you may be just issued with the scale factor and the distance from the center of enlargement to the object, but denied the image, but given the sides of the object. To do that, just construct, then you extend the distance from the center of enlargement to the object. You extend it out. After extending, use that relationship of how to find the center of enlargement to find at the position where you should place your image. After finding that, then construct the respective image vertices using the center of enlargement, scale factor, and the vertices or the corresponding vertices of the object. In that, I believe you will understand how to work it out. Maybe this can also be done on a Cartesian plane, whereby you will be now using coordinates. The same rule still applies, but only here the coordinates is what will vary. For example, the center of enlargement may be at this point, and this may be 2, 4. So you will find that in working out inside here, you will be given the vertices. For example, this may be 2, let's say 4, then 6. The coordinates, you will be given in terms of coordinate, the vertices. And even here will be like, maybe let's say 2, 1. Here maybe say 6, -1. And the same applies to the other. So you will find it goes that way even here. So what you will be doing is the factor or the scale in between here is what you will be using to construct, and also the lines. Just draw and construct the way there. Maybe you may be issued with the coordinates of the image, coordinates of the object. Please do construct the same, and you will find the center of enlargement. And also the scale factor is just easily to find. You will count the number of the square units you will have in between from here to here, and you will find out your scale factor. Or you take distance from here to here, over the distance from here to here, and you will find out your scale factor, and you will have identified the center of enlargement and the scale factor of enlargement in that given sum. Now we are going to learn more about negative scale factor. First we have learned positive scale factor, and now we want to consider negative scale factor. Under here you will find out that we have some of the scale factors. If they are negative, they give a certain condition to a given image after being enlarged. For example, we want to consider an image in form of a letter, or just letter. Let's just take a letter, and especially we take letter A. If we have that kind of a letter A, you will find out that if this point here is our center of enlargement, let it be at point O. You will find that in case we do this in a positive enlargement scale factor, that means if we have a linear scale factor which is positive, for example, let's say that of 2, then we are required to find the corresponding larger side of, or the corresponding image of this. Under scale factor 2, you will find that given this O as the center of enlargement with a linear scale factor 2, you will find the image PQR is going to be enlarged to give us image P prime Q prime R prime as this one, as you can see. But if the linear scale factor is given and it is negative, for example, we use a negative linear scale factor, then this image here, or that given image, this object or that given image will now be turned in that the negative scale factor will take this to the other side through the origin. So it will be to the other side of the center of origin. So what do? You extend these lines of enlargement here to the other side there. The same applies to this. You extend them, so that is wrongly extended. You extend them to the other side, and you will find that if you draw it, you are going to have another kind of a figure similar to this, but much more enlarged to this. So meaning that the scale factor will be the distance from here to the image, and the distance from here to this object will be that the ratio will be equal to 2, such that the image is being formed virtually behind this what I've drawn. So if I may put it at the center, you're going to have something, let's say, from what we have done, we have witnessed that In obtaining the negative scale factor of a given two figures, we have seen is just similar to just that of obtaining the positive scale factor of a given image using a given object. So we can simply say that as from here, you have seen the object and the image formed are on the opposite sides or are on opposite sides of the center of enlargement. This is on this side and the other one is on the other side. So I will give you one example, and that one you will work it out as an exercise, whereby I have a rectangular based. Let's just take a rectangle measuring. It's a rectangle measuring 3 centimeter and 5 centimeter, meaning 3 centimeter is the width, 5 centimeter is the length. Then I want you to enlarge it under a scale factor, linear scale factor 3. So it will be -3. Enlarge it under negative scale factor 3. That is measuring 3 and 5. We have already learned on how to find and locate linear scale factor. And now here, we are going to learn how we can find area scale factor. Before we do that, we are going to consider two similar figures so that we have a rectangle, one measuring 3 centimeter and the other side measuring 5 centimeter. And we have another larger rectangle such that it measures 9 centimeter and the other one is 15 centimeter. And you'll be required to find the area of each of them, and you will find that the area of a given rectangle, we do know that from the area of solids, you will find that the area of this one is length times width. And here, according to what we have, let's just take this side 15, this one is 9. Such that the area of a given rectangle is length times width, and if that is the case, then our length here is 5 centimeter. We shall multiply it by width, which is 3 centimeter, and we shall find 15 square centimeter. If we go for this case, we shall find out that area will always be having the same formula. So that is of a rectangle is length times width, and if we work out, we are going to have 15 centimeter multiplied by 9 centimeter for that case, and you will get 135 square centimeter. So after doing that, we can relate the two and find out what relation does the two have. Since they are similar, we can see they are similar. The two rectangles have similar figure, or they are in similar figure. So we can relate the two areas and find what relationship does they have. Let's take this one here to be as our image and this one to be our object, and we do say that this one underwent a certain enlargement in order to become the way it is from the given figure here. So that we can say if we take 135 square centimeter, we do divide by 15 square centimeter, we should get a certain relationship. And if we work out, you will find out a given relationship from linear scale factor. If you do this, we are going to have 5 here will be 3, 5, 7. You are going to find your answer is 9 without units. So we are finding that the area scale factor from there, whereby we use the area to find a given quotient or the ratio between the two areas, we have found is 9. But if we work out the linear scale factor from the two, you will find that linear scale factor will be equal to, let's take the corresponding sides, and we may take a corresponding side such as 9 over 3, and that is going to give us 3. So we are getting linear scale factor as 3. But remember, area scale factor, we got it as 9. So that implies that if we want to find area scale factor, is the same as taking linear scale factor, then you do the square. Since 9 is the square of 3. So if that is the case, then if we do 3 squared, we are going to have 9, and this 9 is here, and that is our area scale factor. So that simply means to find area scale factor is the same as taking linear scale factor squared. We shall view one of the example here. Here we have two kinds of cones with a slant height of 3 cm and 21 cm. If the two cones are similar and are of a circular base, and one of the area of one of the cone, which is the smaller cone, is 21 square centimeter. Find the area of the larger circular based cone. So here, to find the area of that, what we are required here is to find the area scale factor first. Then, since the two cones are similar, we need to find area scale factor of these two cones. And to find that, we need first to have linear scale factor, since the slant height of each of the cone we have been given. So to find linear scale factor, we shall find it by taking the slant height of the larger cone over the slant height of the smaller cone. And if that is the case, the slant height of the larger cone is 21 centimeter and that of the smaller cone is 3 centimeter. If you find the quotient or the ratio between the two, you are going to get that the ratio is 7. So implying that our linear scale factor here is equal to 7. But the area of the circular based cone here, as we have here, we are finding that the area of that smaller cone, the smaller circle cone, we are finding it is 21 centimeters. So we need to find the area of the circle of the larger cone, the lower part. That is what we mean. This one here, we can extract this part here and say that is 21 centimeters. That is what we are viewing as an oval. So this is what we have. And this one here also, we can extract it and we shall have a larger cone, a larger circle. So this is what we need to find. From here we know that this is 21 square centimeter. And this one here we don't know, but we have linear scale factor. So what we are required to do here, we need to find area scale factor. And from our previous discussion of that subtopic of area scale factor, we did say that to find it is like to find area scale factor, you have to take linear scale factor, then you do the square. And if that is the case, linear scale factor here we have a 7, and if you square 7, you are going to get 49. So using 49 as linear area scale factor, you can find the area of the circle or the circular based cone here. So you can find the base of that cone, and to find the base, you will say that let this area be x, and if you take that area, the ratio of that area over that of the smaller cone, the base of that smaller cone, you should get 49. So that implies that you can work out cross multiplication, and you will find that your x is going to be 49 multiplied by 21. And let's see, what do you find? You will find that if you calculate this one on long division, you are going to get, this one is going to give you 1029 square centimeters. So meaning that the area of the base of that larger cone is 1029 square centimeters. So that one we have worked out using the area scale factor formula, and we have seen how it has helped us with the computation using linear scale factor. So you can use the two to relate each other and work out in either case you have been given any kind of computational problem involving area scale factor and linear scale factor. Let's consider two cuboids here. This one here having measurement of 2 centimeter, 4 centimeter, let's just say, be realistic, 6 centimeter, 4 centimeter, and here 2 centimeter. And you find out that this one here is having 12 centimeter, this one is 8 centimeter, and this one is 4 centimeter. So meaning the height of that other cuboid is 4 centimeter. So in that case, if we have the two, you can calculate the volume of the corresponding cuboids, and these two cuboids are similar. They are similar in that if you calculate the volume, they will have a certain kind of relationship in it, such that let's calculate the volume of this cone and this cuboid. The volume of this cuboid will be length times width times I. And if that's the case, you will take 6 by 4 by 2, and this one you're gonna get it at 48 cubic centimeter, because we are dealing with the volume and it's 3-dimensional. So you will find is 48 cubic centimeter. The same apply to this. We can take the volume of this one, and you will find the volume will still be length times width times height, and this one is gonna give you 12 centimeter multiplied by 8 centimeter by 4 centimeter, and you will find out that you are going to have 384 cubic centimeter. So if you view the two, you are getting that this one is 384 and this one is 48 centimeter. But if you find out the relationship between them, meaning that you go ahead and find the ratio of the volume, the two volume of the cuboid, you will find that the ratio of the larger volume over that of the smaller volume, which is 48, will be equal to, you will find out if you divide 384 with the 48, you are going to get here will give you 4. So you will get, is actually not 4, it's going to give you 8. Yeah. You get it as 8. So meaning that this 8 here is the same as taking 2 cubed. You will find it's 2 cubed, but it is 8. So you can write it as 2 cubed or just leave it as 8. What is the relationship between volume scale factor and linear scale factor? You will find out that if you take the corresponding side of the two similar cuboid, that is 6 centimeter and 12 centimeter, you will find out that to get linear scale factor, remember we said that linear scale factor can be obtained by taking now this side, which is length of the larger cuboid, over the length of the smaller cuboid, and that will be 12 over 6, and you will get 2. And remember this 2 here is our linear scale factor. But volume scale factor, VSF, abbreviated as VSF, we found it as 8. And remember these 2, if we do cube these 2, we are going to get 8. So meaning that if you take 2 cubed, you will get your answer as 8. But in other way, this is just the same saying that if you take this 2 cubed is 8, but 2 cubed is volume scale factor. So if you find this 8, it's just the same as 2 cubed, but 2 alone is linear scale factor. 2 alone is linear scale factor. So if you cube, it's like you are cubing linear scale factor. So that implies that to find volume scale factor, you need to take linear scale factor, you cube it, and then you will find the volume scale factor. And you shall be using that information to calculate out the volume of various figures you may be given, which are similar to each other. Sometimes you may be required to find the volume whereby you are being issued with the area scale factor. We shall do an example whereby you are being given volume of one object which is similar or of the two, and you will be asked to find the volume of the larger object, but you are being issued with the area scale factor. For example, a student saw a square-based prism with two square-based prism which was similar, one having a volume of 25 cubic centimeter. Find the volume of the larger square-based prism we saw if the area scale factor is 9. Here, what you are required to do is first analyze the question. We have area scale factor, but remember, to find area scale factor, we say that area scale factor can be obtained by taking linear scale factor, then you do square. So meaning that if you want linear scale factor, then you have to find the square root of area scale factor. So meaning that in this case, if we need linear scale factor, we are required to find the square root of 9, and we shall find it as 3. So if that is the case, then it means we are going to find linear scale factor as 3. But remember one thing. Here we will be issued with 25 cubic centimeter as the volume of the small square-based prism. So we need to find volume scale factor in order to compute the volume of the larger square-based prism. So what we shall do here, we need this volume scale factor, and this volume scale factor from our previous session, we did say that we can find it by taking linear scale factor squared. So we shall find volume scale factor by taking linear scale factor, cubed. If we square, we shall be finding area scale factor. So if we cube, we shall find volume scale factor. So that's what we shall do. So here we are going to take 3 cubed, and if we take 3 cubed, we are going to find this one is going to give us 27, and it has no units. So that is our volume scale factor. So that means that if we take the volume of the larger prism over the volume of smaller prism, we are going to get 27. But what is the volume of the larger prism? We don't know. So we can give it letter X to imply that we don't know, but we are looking for it. So if we take X over 25 cubic centimeter, we shall find 27. So meaning X can be obtained, and to obtain X, you can find it by just cross multiplication. And if you cross multiply, you are going to get that X will be equal to 27 multiplied by 25 cubic centimeter, and this one is going to give you 625 cubic centimeter. 675 cubic centimeter. So that is the volume what we will find if you cube linear scale factor. So that is what we are going to get. With that, we have come to the end of volume scale factor, and I believe you can compute any kind of given problem involving either volume scale factor or linear scale factor or area scale factor. Just know the relationship between them, and it only applies to those figures which are similar in shape and fulfill the conditions of similar figures. With that, we have come to the end of the topic similarity and enlargement. I believe that lesson has been much more interesting. See you in our next videos.